You're all very familiar with the geography here. Our sampling location is shown here in the star. I want to just provide a little bit of context about the community of West Oakland, which is your nearby neighbor, and not just the truck emissions, but the emissions from the ships and the railroad locomotives and all of the yard equipment operating at the port. There's a lot of diesel engine emissions at the port, and communities, people living in West Oakland are potentially, in close proximity and exposed to those emissions. So that's some of the motivation for all this effort to clean up diesel emissions of various kinds, not just from trucks, but also the ships, for example, are burning a much cleaner fuel now, and that's been looked at as well. There's been some confusion about this study that we've done on the Bay Street Bridge over 7th Street. The Bay Area Air District, I don't know if I can, is this a pointer here?
Yes.
There we go. So there's a West Oakland monitoring site that the Bay Area Air District operates. That's just measuring ambient air. It's not measuring emissions from a particular source. And so that site there is there's been some confusion between what we've been doing here and maybe what's been going on at the Bay Area Air District's West Oakland monitoring site. There's also been field work going on in the port's maintenance area. You see those white roof buildings there. And so there's been a lot of study, I guess, of what's been changing in the port. Some of that's been open air, ambient atmosphere. The study I'll be talking about is specifically directly measuring emissions from the trucks, not general air quality at the port. It's measuring specifically the emissions from trucks, and I guess there's been, I haven't been directly involved in those discussions, but there's been, I understand, some controversy about whether our results reflect just the truck emissions or sort of area-wide air quality at the port, reflecting all sources. The answer is no, this is really, our study's really, this one, right, is just about the truck emissions, nothing else. So there we are, my graduate students hiding inside this van. You'll notice we've got an aluminum duct here hanging over the bridge, and these trucks mostly have vertical exhaust pipes, so they blow exhaust almost directly into our air sampling inlet, and we're able to make fast response measurements here. And so long as the trucks come by one at a time, if they come by four in a tight pack, then we just see sort of a broader peak of the four trucks together. But if there's a little bit of spacing between the trucks, we can see them individually and what the emission profiles look like as they come behind. Here's my technical detail slide on all the measurements we made. Sort of a key feature of this approach is we measure CO2. Most of the diesel fuel, when you burn it, comes out the tailpipe as CO2. So we look for the CO2 to make sure we see a truck actually burning fuel as it goes by. If we don't see CO2, it's a failed measurement. We just can't pick up the emission signature from that truck. So we look to make sure, first of all, that we see the CO2 plume in the exhaust. And then if we do see that, we look for these other pollutants, particulate matter, the black smoke or black carbon, which is one of the main parts of the particle emissions. And then we also look at this gaseous emission, nitrogen oxides, which wasn't really the focus of this first phase, but that's maybe more under discussion for the second phase of the truck replacement and retrofitting program. We make use of NOx, I guess, to replacement, doesn't it? So I have a short and really exciting movie here to show you, and it's I'm going to show you just only 15, 20 seconds. I've got hours of movie like this. If anyone would like to come and see more, we can share beer and watch this kind of movie for hours. It's exciting. So
come down to the Siemens Center and watch it
we
there.
Can all,
Perfect.
I think there's probably more exciting things we could do with our time together. Then watch this extended movie. I need to get this movie to play. And here we go. Yes. Okay, so these colored, there it goes by the first truck. And in red down the bottom, see the CO2 spiking up and all the other pollutants, NOx, and the particle pollutants in blue and black spike up together. Here comes truck number 2. And there's spike number 2 in the measurements. Okay, so this is what I'm saying, that we're really capturing individual trucks and we're measuring directly and specifically the emissions from the trucks as they go by. There's truck number 3. Kind of interesting there, that tractor on its own we don't really pick up. There's maybe a tiny little shoulder here, but that wasn't burning enough fuel to really see a big CO2 plume. I think there's one more coming. Yeah, here we go. Okay, and there's you see how it works, right? We're making measurements at fast time response, and if there's enough spacing between the individual trucks going by, we can really associate those spikes in the measurements with the exhaust emissions of that truck coming out the tailpipe of that truck as it drove by. A couple other points I want to make, that we're measuring the baseline. There's been this controversy that our measurements reflect just the general air quality in the port and the ship emissions and the railroad locomotives, it's all mixed in. Well, that's true, that this baseline here includes maybe some emissions from other sources. It's probably mostly just general kind of residual roadway pollution from trucks that drove by earlier. But maybe there's a little bit of ship and locomotive signature in the baseline, but we subtract that out. Okay, so even if it's present, we just measure the spikes above the baseline. So we really are just looking at the emissions from that truck as it drove by, nothing else. Everything else we subtract out, and kind of by design, we're focused on the truck emissions anyway. The other thing I want to point out is, you notice how we had, well, there was the tractor, but there were four big trucks that drove by, and we see 402 CO2 spikes, one for each of them. And we also see 4 NOx spikes. But it's kind of interesting to me that we only see 2 of the trucks that had detectable PM. Right? There's 2 more trucks here that have lots of fuel being burned and no PM emissions. So we had about, in the June 2010, our second measurements, about 15% of the trucks had 0, unmeasurable PM emissions. That's good, okay? We didn't exclude those trucks. We said one out of 6, roughly, 15% of the trucks are so clean they have unmeasurable PM emission levels. And that number was only 5% back in November 2009. That's not the whole story, right? There's still lower emissions from the trucks where we can measure. But there's what I would describe as 1 out of 6 trucks at the port now is so ultra clean in terms of PM emissions anyway, that we can no longer easily detect the PM emissions from those trucks. So that's good news. Okay. So a little bit of summary of the results now. I think I wanted to give everyone a very clear idea of our methods. I feel like that's important just so we're kind of on the same page and clear about what we did and what it speaks to. And then this is my last slide. So the key results that you'll be going to be interested in is between November 2009, our first measurements, and June 2010, we saw a 50% reduction in the average emission rate for all the trucks together. Right? There's, well, something on the order of 1,000. It's not quite that big. I don't recall exactly the numbers, but it's at least hundreds of trucks measured in each of the 2 campaigns. So 50% reduction in emission rates of particulate matter and the black smoke or black carbon in particular. And then also a 40% reduction in nitrogen oxides. And when we first got that result, we really scratched our heads. We said, wait a minute, putting these diesel particle filters, which all the 94 to 2003 trucks had those retrofits done, that should have really lowered the PM, but it didn't really affect the NOx emissions. So we scratched our heads and said, what is going on? It didn't make sense to see such a NOx reduction. And what we ended up deciding after we looked more carefully at how the age distribution of the trucks changed is that the diesel particle filter retrofits was part of the story, but a lot of it was this updating of the truck fleet. So the 2004 and newer trucks coming in, and the 93 and older trucks getting retired or moving into other service, that updating of the age distribution was also helpful both for PM and for NOx. So we think the diesel particle filter, well, both factors, the diesel particle filters and the newer truck fleet helped here, and this 40% we think is almost entirely due to newer trucks and not really an effect of putting the diesel particle filters. Some of them may have small NOx benefits, but that's really focused on particle emissions, not on NOx. So I guess I've just said that. What I think is most striking about this, my research group's been making measurements of the Caldecott Tunnel since the 1990s. So we were looking at reformulated gasoline and car emissions, and we started doing diesel truck emissions back in the 1990s at that site as well. And over a period of about 9 years, between 1997 and 2006, we saw kind of 50% reductions in PM emissions. Over 9 years. These reductions here at the port happened in 9 months, less than 9 months. So that took some pretty significant effort, and it's unusual to get the emissions to come down that much, that quickly. Okay, so I think that's also a pretty significant achievement and unusually rapid progress in obviously pretty major changes to the truck fleet that happened here. And I just thought I'd give this as a point of reference, as a perspective. If you just let things kind of gradually turn over by owner-operators deciding, okay, it's time to replace this old truck, let's bring something new in, that's a very slow process. And this cleanup of the port trucks happened in comparison very, very rapidly.